Hello there, and welcome to your video on the Build an Atom simulation on the PhET website. You can see here at the top of your page, I went ahead and put the entire URL. Type it in exactly to find this. If you're having issues getting to it this way, I'm going to show you another way in class to get there, but this is going to be the quickest way for you to do that. You will also notice that in the place on my website where I've put this video, I also am going to have put in the hyperlink so then you can click on it directly. It tells you what the settings are here. Let me go ahead and show you what it's going to look like once you get there. Do realize there are three versions of this. The one that you want is Atom, not the one that says symbol and not the one that says game. So when you get to this page, this is going to be closed and it's going to have a green plus here. This is going to be closed and have a green plus here, and this is not going to be checked. What you want to have your screen look like is exactly like this. You're going to want to make sure this is open so you can see net charge, and you're going to want to make sure that this is open so you can see mass number. Remember that this is the number of protons and neutrons, which is what is contained within the nucleus of your atom. Up here, you're going to see a count of protons, neutrons, and electrons. Definitely pay attention to that when you're being asked if something is neutral or if it is an ion, and I'm going to show you what that looks like in a second. The only things that you can manipulate here are the protons, neutrons, and electrons. You can grab those with your mouse and then drag them where they need to be. Protons and neutrons will go in the center, and electrons will go in one of these two rings. For this class, don't get caught up in those two rings. That there's a purpose to that. In a straight up chemistry class, for us, we're not as concerned with how many electrons go on which level. So don't get too wrapped up in that. Okay, so this is going to be your default screen. So your excuse me, your first assignment, you can answer that right now. Anywhere where it says play around, that doesn't mean go to the game. It simply means play around with this. So you can make up any atom that you want at all, right? How many protons and neutrons there are to make sure that it's stable. As an example, I went ahead and built carbon. And how do I know it's stable? Because it literally says it's stable. For this particular one, you are not worried about that word right there. You're only concerned about the center. Draw your nucleus. You're just drawing how many protons and how many neutrons are in here. You can either use color or you can label the protons P and the neutrons N. And then what element is it? It's going to tell you right there. It will also tell you right here on the periodic table. Here, play around until you discover which particle or particles determine the name of the element that you built. What did you discover? This is where you're going to want to layer in some electrons. All right, so you're going to build something until you get this word right here, neutral atom, and also that it has a stable nucleus. Once you get an atom that you like, pull an electron away and put it back and see what happens to the name. Pull a proton away, put it back, see what happens to the name. Pull a neutron away and put it back and see what happens to the name. Whichever particle or particles make that name change, you're going to write that in here. Okay, second page, you're literally going to build these and then do exactly what I said. Pull a proton away and put it back. Pull a neutron away, put it back. Pull an electron away, put it back. And that will tell you what determines the element. When you pull a particle away and it changes whatever name this is, that particle determines the element. And they want you to circle where it is here, which shouldn't be difficult because it's going to show up right here for you. Then you have some definitions. All right, what makes an atom neutral? One with no extra charge. In other words, what is it about this that makes it neutral? The way that you find that out is pull a particle away and put it back and see if that changes. Do that with all three particles. And then once you have something that's neutral, see if you can develop a pattern here. All right, so you're going to do that with all of those. Here, you can choose anything you want at all to draw here, but you're not only going to draw the nucleus, you're also going to draw the electrons and then write down what the charge is. For the neutral one, you should be able to write down what the charge is right now. Again, look at my examples. Here's a neutral atom. Here's a positive ion, okay? Again, how do I know that? Because it literally says it here. If it's going to be negative, it'll literally say it right there in the corner. And then the last page that you absolutely need to do is this one. Here is how you handle this. Build yourself an atom, a neutral atom. It doesn't, excuse me, it doesn't matter what it is. You can even build this one if you want to. Then use this to do this. This says add a proton. So you'll build this, add a proton, tell me, does the element change, the charge change, and the mass number change? There's the element, that tells you the charge, and the mass number is right here. Once you have done that and described how it changes, do the opposite of that, take that proton away. Now, remove a neutron, same thing. Go back to this original element. Now remove an electron, and so on and so forth. Always go back to whatever your set neutral atom is before you do one of these processes so that you can say how it changes. You are only obligated to do these first 3 pages. This 4th page, which is right here, it says challenges. All of this all together is going to be worth 6 points of extra credit, so it is entirely up to you to do that. When it says design a positive ion with a charge of 2+, how will you know it's 2+? That will appear up here. As an example, the charge on this bad boy, it tells you right here is +6, okay? So you can just play around until you get one that's +2. Any atom at all, it doesn't really matter. So yeah, that is how you attack your homework. If you have any other additional questions, please come see me during lunch.